Good morning, everyone. This is Shauna, and this morning I'm coming to you with a video from 6.2, the last two problems of 6.2 that have to do with normal distributions, but in a little different way. We're solving for unknown values based on areas that we find in the problem itself. So let me, at this point, bring up the homework for you so you can see what I'm talking about. Oops, let me do something here. Let me make this this larger so we can see it. Okay, so here, let me start with 20. I'm actually going to start with 20 and work backwards. 20 is the one that's more complicated. It says in a certain normal distribution, 1.25% of the area lies to the left of 42, and 1.25% of the area lies to the right of 48. Find mu and sigma. Okay. So what we're going to do here, I'm going to share another screen. We always start by drawing whatever distribution we can. So what I'm going to do is I'm going to find that on my screen. Let me come over here and open my folder. Give me a moment. Okay, so as we can see, and here I've reproduced the problem for you. In a certain normal distribution, 1.25% of the area lies to the left of 42, and 1.25% of the area lies to the right of 48. Find mu and sigma. Sometimes students get this confused, especially if you're reading just the first part, and they don't know where to put the numbers. So you know that a small portion of the area lies to the left of 42. So there's only a small portion of that area. So 42 has to be somewhere in the left tail because only a small portion lies to the left of it. All right. And by the same token, 1.25% of the area lies to the right of 48. There's only a little bit of area that lies to the right of 48. So you know that you're not on the same side and mu is larger. This is 0.0125, okay? So what I'm going to do now should be familiar to you. I'm going to get the z-scores that correspond to each of these x values. So for x equals 42, z equals the inverse norm of the area. Remember, when I use inverse norm, I want the area to the left of whatever my value is. So here, this is my x, and I'm looking at the x, and I want the value that is to the left of it. So 42 there, okay? So inverse norm, 0.0125, you should get negative 2.24. Let me switch screens and show you that. Now, recently, my emulator was updated, and it was updated to the TI-84CE. So this may look a little different from your calculator that you're used to, but it's got all of the same functions. It has a little bit of a different layout on some of the screens, but the keystroke sequences are very similar. So let me do something here. Let me change the mouse and move this up so I can make this full screen for you. There we go. And as is normal, we're going to second distribution. And it's going to be inverse norm this time, number 3. Now, something different about the CE is that it'll give you left, center, and right. If you're on the 83, 84, you don't have this tailpiece. It's just going to tell you tail, all right? But the area that I put in is I'm going to put in 0.0125, 0 and 1, and I'm going to paste it. And that's going to give me negative 2.24, as I said. Now, on the right side, if you recall, let me share the picture again. On the right side, we have 48 right here. And I need all of the area to the left of this. So I need all of this. I need all of this area here, okay? So what I'm going to do is I'm going to take 1 minus 0.0125 for my inverse norm. So let me go here and do that for you. This is second distribution. Let me get the mouse cursor back. Second distribution, inverse norm, number 3. This time I'm going to put in 1 minus, and I use the minus. This is 0.0125. And I'm, again, the left, enter. And I get the positive z value, 2.24, as you might expect, because the areas are the same. So one's positive, one's negative. Now that leads us to the following. I then have 2 z-scores, but I have 2 unknowns, okay? So our formula here, z equals x minus mu over sigma. In case you can't read this on the screen, this is negative 2.24 equals, this should be 42. This is 42, this number. This is your left x value, 42 minus mu over sigma. And positive 2.24 is equal to 48 minus mu over sigma. Okay, so I generate one equation for the left and one equation for the right because I'm solving for 2 unknowns, mu and sigma, and I need 2 equations to do so. So from here, we're going to go on and solve the system. I used a combination of the elimination method or addition and substitution. You'll see what I'm talking about as we go. So here, I reproduced the equations for you down here. Let me clear the drawings. I reproduced the same equation. So if I take the equation on the left-hand side, which is negative 2.24 is equal to 42 minus mu over sigma, I multiplied both sides of the equation by sigma. So I have negative 2.24 sigma is equal to, and here the sigma cancels, 42 minus mu. And similarly with the other equation, 2.24 sigma is equal to 48 minus mu. Now, something really interesting happens here because you'll notice these, so let me mark it here. This is the opposite of this term. So that makes it nice to use elimination on that. So what I did was I wrote the equations underneath one another. And then after writing the equations underneath each other, I just canceled out the 2.24 sigma. And you're like, but wait a minute. I thought we wanted to solve for sigma. We do, but we can't solve for both variables at the same time. So what happens here is I'm eliminating sigma and I'm going to solve for mu. So 0 here is equal to 90, which is 42 plus 48. And then I have minus 2 mu. So if I add 2 mu to both sides, I get 2 mu is equal to 90, and therefore mu is 45. Now, you can do this a couple of different ways. You can go back and solve for sigma separately, or what I did here was I went back and used the second equation, and I knew what mu was because I just found it. So I plugged it in there. I used substitution and then solved for sigma that way. So you have some choices, but my work looks like this. So I used this equation, as I mentioned, plugged in 45 where the mu was. 48 minus 45 is 3. So I have 2.24 sigma equals 3, divide by 2.24. And 3 divided by 2.24 is in fact, let me show you, 3 divided by 2.24 gives me 1.3393 because it's 2.8, so 1.3393. And that is problem number 20. That's the hardest one in there. 19 is similar, but it's not quite as hard. So let's go back and do 19. Now, hold on, let me rotate this back to the homework questions so we can see what we're doing here. I'm gonna drop that down. Okay, so now there's my homework. And if you look, scroll down in this window. So it says, in a normal distribution, find mu when sigma is 6 and 3.75% of the area lies to the left of 85. So again, if you're not sure where this goes, there's only about 3%, maybe 4% of the data to the left of 85, close to 4%, right? So it has to be in the left tail. If it were over here on the right, there would be a lot more data to the left. So we have 85, and we do our familiar inverse norm of the area that we're given, which is 0.0375. So Z is the inverse norm of that. Let's verify that with the calculator. So we have, let me put it up here for you. We're going to do second distribution, inverse norm, number 3. And I'm going to clear this out. And I'm going to put in 0.0375. Again, I'm in the left tail and I paste it. and I have negative 1.78 as my z-squared, negative 1.78. So now I'm going to say, all right, well, negative 1.78 is my z. And remember, I have my x is 85. What I don't have is mu. So I have negative 1.78 is equal to 85 minus mu over 6 over sigma. Now again, we multiply both sides by the denominator. So I'm going to multiply both sides by 6. 6 times a negative 1.78, we have this 6 times a negative and the negative, remember, is down here with the plus minus. So I'm going to move this down. And I'm going to say that this is a 1 point negative 1 point. I think it's not going to, hold on. Let me move this up. There we go. Having some issues with the give me a moment. One more time, 6 times a negative 1.78 gives you negative 10.68, which you can see from the screen. This is, let me pull it up. This is negative 10.68. Now I'm going to subtract 85 from it. And that's going to be the opposite of mu. So I need the positive portion of mu, and I get 95.68, which is what mu is. Okay, so that takes you through problems 19 and 20 from chapter 6.2. I hope that this video has been helpful to you, and I look forward to seeing you in my next video. Thank you so much for watching. Bye for now.